A very good evening, students. Today we are going to see the topic energy management strategies. This comes in unit number 3, that is requirements in hybrid electric vehicles in electric vehicle system subject. Why management strategies are matters in EV? Because the energy has to be used in an efficient way in the electric vehicle, balancing the energy consumption, performance, and range in EV. By having a proper energy management, we can save the battery life, or we can enhance the battery life, improves the vehicle efficiency, reduce the environmental impact. This is the simple flowchart which tells more about the energy management. You could see that the energy management block is the main fundamental block. It has the interaction with supervisory controller, and the command passes to the powertrain. So based upon this energy management decision, the mode selection and the powertrain operation will be decided. And the command goes to the speed controller. It is a closed loop control. This is the block diagram of an EV. Actually, this is an hybrid EV. You could see that motor and a few IC engine both powers the electric vehicle, and also the motor is being powered with the help of battery, and fuel tank is mainly placed for giving fuels to the IC engines. So the hybrid concept is one of the interesting concept. We could take advantages of both EV and IC engines, but only thing is it will make the overall system complex. You could see n number of blocks integrated together to working function is a very tedious process. If any one malfunction occurs, that will disturb the others. Objectives of energy management: maximize the driving range, optimize the battery life and health, ensures the safety and thermal stability, enhance the driving performance, integrate with renewable energy sources. What are all the key energy management strategies? The first one is battery management systems, and second one is regenerative braking. In that, the state of charge monitoring, SOC monitoring, and SOH estimation are important. And third one, the thermal management for optimal battery performance is also important. So we have to maintain the thermal level in a battery to a greater extent, because if it is not maintained, that will lead to fire hazards. So the regenerative braking captures the kinetic energy during the braking and converts it back and saves it in the battery. Then third one, thermal management. Fourth one, eco driving modes. So eco driving mode prioritize the efficiency over performance. In sports mode, the prioritize the performance over efficiency. What are all the advanced energy management strategies available? The first one is an artificial intelligence and machine learning. It gives predictive energy management based upon the driving patterns, and then real time energy optimization. Second one, vehicle to grid technology. EV act as an energy storage for grid and bidirectional energy flow for vehicle and grid. Then smart energy management systems integrates with home systems and renewable energy sources. So these are all some energy management strategies which has been mentioned in the block diagram. With the help of the energy management systems, we can optimize the performance of electric vehicle. In that block, you could see energy sources, power electronic converters, EV chargers, energy storage system, then local loads, utility grid. So what they're trying to convey is this EV can take power both from local loads and also from the utility grids based upon the requirement and optimization of the EV. It will switch over, and also it can able to give back to the grid if energy is in excess in the EV. These are all some energy management branches. One is a rule based control strategy, and second one is an optimized based control strategy. In that rule based control strategy, deterministic rule based control strategy and fuzzy logic rule based control strategy are available. In optimistic based control strategy, global optimization control strategy and instantaneous optimization control strategy are available. Then we are going to see now the regenerative braking in detail. In short, regenerative braking turns emotion into energy, which is not used for the run. How it works? Converts the kinetic energy into electrical energy, stores the energy back into the battery. What are all the benefits? It increases the range, it reduces the brake wear and maintenance. Then main role of thermal management is to keep the cool, but main challenges are battery generate heat during the charging and discharging. Excessive heat can degrade the battery life and reduce the efficiency. The following are the solutions available for the thermal management: liquid cooling systems, heat pumps for temperature control, then smart ventilation systems. Then another interesting one, AI and machine learning for energy management. So everywhere the AI plays a major role. It is revolutioning the world now. So in this EV, we can use the advantages of AI and machine learning for smart energy management. It uses the GPS data, driving patterns, battery state, and external conditions, and also by giving an predictive maintenance and adaptive energy optimization based upon the driving behavior, real time route optimization for maximum efficiency. These are all some case studies related to the energy management system. Tesla uses the energy management by AI for optimizing the battery performance and integration the Tesla supercharger network for fast charging. The next one, Nissan Leaf regenerative braking for enhanced range and eco driving modes for efficiency. Then third one, BMW i3 advanced thermal management for improved battery life and seamless integration with renewable energy sources. These are all some future trends in energy management. The first one is on wireless charging, second one solid state batteries because the higher energy density faster the charging. Then integration with smart grids, energy harvesting which utilizes the solar panels and other sources for auxiliary power. So the final conclusion is the energy management is future for this EV. We can able to optimize the energy performance of the electric vehicle with the help of this energy management. Key takeaways are energy management is crucial for EV performance, efficiency, and sustainability. Advanced technology like AI and regenerative braking and thermal management are reshaping the industry. Mainly, the innovation will drive the future of e-mobility. Thank you for your patient listening. We'll be discussing another interesting topic in the upcoming video. Thank you all.